Ladies and gentlemen, thank you for your patience. And here's Miss Laura Wieme.
There you go.
Hooray!
Hi again. I'm Laura Wieme. I work with Intel's game team. I'm a graphics programmer. And then I also mentor for Udacity's VR Nano degree. So this talk is really important to me, and I wanted to let UX designers in on VR optimization, because you really have to plan for it from the start. You have to design for it from the start. Otherwise, you're going to hit all sorts of bottlenecks and headaches trying to get different physics interactions to work, or wonder why your user is getting sick during user testing because of low frame rates or dropped frames. So it's going to get a little technical because this is a huge topic. I'm going to mostly talk about Unity because that's where I've found a lot of people are more familiar with. But the main takeaway I want you to get from this is it's a lot of details. It's a lot of new technical jargon, but just be thinking about optimization from the start. And if you need to look up the terms later, go and do that. So why is optimization so important? I covered this a little already, but we all know that users are getting sick from VR, so you don't want an experience that does that. That's the worst review you can get on a VR app is, I wanted to throw up after 5 minutes. That's not going to sell your app. So you want to keep consistent frame rates and not drop those frames. With optimization, you also get more room for bells and whistles. Like, users love physics in VR. They want to smash everything. They want to throw everything. Well, unless you're optimized, that's going to get really slow and laggy the more like blocks and balls the user is throwing. The other thing I want to point out is, especially with the release of the Wieme MR headsets and standalone VR headsets and mobile VR, you're really going to have to concentrate on your performance because these are shrinked down platforms. They don't have the big monster computer pumping out frames for you. So you're really going to have to optimize to have beautiful immersive experiences on these shrunken platforms. So the next one is a quote I liked from NVIDIA that said, "Virtual reality requires 7 times the power of a normal game." I mean, that's going to vary depending on what games you compare, but that's huge. And for a graphics engineer, that's like, holy cow, my job just became a nightmare because now I have to do 7 times the work. So this is the other thing everybody asks, especially consumers. They're like, why do I need this giant graphics card all of a sudden? You know, I've been playing my video games just fine with this one. Why for VR do I need a crazy expensive video card, like a whole new motherboard and processor? The thing is, most AAA titles, these are from the big studios, render between 30 and 60 frames per second. 60 frames per second on a normal game on one screen is usually pretty good. But for VR, you need to be at least a steady 90 frames per second. Some developers will even target 120, but it's better to maintain that steady 90 than to occasionally pop up to 120. So try and keep it steady and 90 frames per second. It's a lot. Because you have 2 eyes in the display with different perspectives, now you're rendering everything once per eye. This, as you can imagine, is a huge cost, especially if you've been working in 3D graphics packages and you know how long some renders can take. There's been some optimizations that have been done, so you maybe don't have to render everything, but you're still at almost double the costs. Besides rendering all your shiny graphics, you have this headset with sensors and controllers with sensors, and that's sending all the different pose information back to your computer. And it's also running calculations to try and predict where the user is going to move next, because you have to have that frame ready for them to see when they move there. We're also warping the images so the distortion is correct for the strange lenses in VR headsets. And then you're compositing things like additional UI, like if you go into Steam's UI, or the chaperone boundaries, like when your user is about to step out of their safe zone. That all gets composited in after. So this all gets really expensive really fast. So a few things that are a headache for VR. I brought this up previously, but players love physics and they're everywhere. Before in games, you used to be able to control what the user could interact with much more strongly. Now the user is set free in an environment and they expect certain things to happen. I made a bowling game and it was pretty obvious, like bowling physics, bowling ball, bowling pins. But then I had some signage and I had a bar with some bottles in the back. And the first user test, why can't I knock the sign over? Why doesn't this bottle smash when I smash it on the bar? They're gonna try these things and it's gonna affect the experience if they don't get the reaction they expect. But things like breaking bottles, all of a sudden you have to calculate the physics on a whole ton of shards. Crazy expensive. Avoid glass bottles. One last thing. Also for VR, we tried to do anti-aliasing. Especially with the screens with VR, or if you're rendering at a lower resolution, you get jagged lines, and with the motion of VR, that can cause like a shimmering effect, and that can actually make some people sick. So if at all possible with your rendering budget, try to include anti-aliasing while doing VR. We found on some mobile platforms that maybe it's too expensive, but also with the smaller displays, it was maybe less noticeable. Okay, now I'm gonna get into a couple tools. I'm just gonna go over this fairly quickly so you know they exist. With Unity's documentation, it's pretty good. They have an entire section on VR optimization. I recommend you look at that page because it will do a quick breakdown, but also links to articles that go in further detail for each optimization concern. So for here with Unity, we have the stats window. This is when you're in your game mode, in your editor, you're previewing the game, and up in the top right corner there, there's a stats. If you click that, it will give you some profiling information like your CPU usage, batching, which is like how many bundles of information it has to send to the CPU. You can also get a rough frame rate from this. The frame rate is okay to use for initial testing, but the important thing to know about this is it's your frame rate from within the editor, not your headset. That can be a big difference. So only use that for rough estimates. To dig deeper within Unity, there's a tool called the Profiler. So this you can use with your headset to get information from the actual rendering for the headset. There's different categories on this, like CPU usage, GPU usage. One that's really useful for VR is there's a physics usage. So you can do things in your headset where you go in and trigger a ton of physics and then go back in and it will show you some of the bottlenecks. This tool can get pretty advanced, but Unity has good documentation. Check it out, try it, it's your friend. Really quick to other tools if you really want to get a bit deeper on this. This is the Intel's Graphics Performance Analyzer. This works on any games you want to profile. What it does is it hooks into your game and it takes a capture of one graphics frame. So then it analyzes the breakdown of like, well, am I doing too much drawing here? Or is there a lot of transparency here? Because transparency can be expensive. You can scroll through resources for your frame like, oh, this texture is gigantic. Why is this texture so huge? So it's a little more of an advanced tool, but out of the advanced tools that I know, I'd highly recommend learning this one because it's also similar to the frame analyzer from Unity, or also Xcode has a frame analyzer that's very similar. This is Intel's VTune amplifier. This one is a bit more geared towards CPU usage. But if you're finding that your GPU isn't really working up to its maximum, you might be CPU bound. So if you think your CPU is doing a lot of work, which physics requires a lot of CPU usage, then you go to VTune. Okay. Now, these are going to be fairly Unity specific on where to find them, but they apply to any of your game engines or games. So physics, our VR friend. One of the very, very common mistakes that beginner Unity programmers and designers make is with physics, they forget to add a rigid body to a physical item, and then they move that item. What happens with that and why it's such a big deal, and Unity should do a better job of flagging this, is that it recomputes the physics for the scene on every single frame if you do this. So if you remember anything, is to check that all your physics objects have a rigid body on them. Then you want to use the simplest collider shape possible. So on the image here, I have a spaceship, and it's got two different colliders. One is a mesh-based collider that's really tightly bound, and the other is more of a bubble. If you can get away with it, try and use the bubble, because the more complex geometry you have for your collider, the more calculations it has to do for all the different places on the collider. And you can get in the situation where you have a convex collider or a concave collider, and it gets very expensive. That's why Unity actually has a checkbox to convert things to convex so that it will calculate faster. Also, just physics drop your frame rate. For Udacity, for their nanodegree program, they use the scene with a room full of trampolines, and they shoot off particle effects when you throw a ball on them and it hits. Immediately, if you run that scene in VR, your frame rate plummets. Okay, so geometry. I'm gonna move quickly on this one. Keep it low. Any geometry that doesn't move, mark as static. This allows Unity to use a mode called static batching, which anything that doesn't move, it can optimize and load up into one big mesh that it processes all at once. So neat optimization that you can get for free just by hitting the checkbox. Levels of details are nice to use. If you've done game modeling before, you've probably heard of it. If not, check it out. Unity in the asset store has tools that will help you automate some of this. Textures and shaders. So the more shaders and textures you have, the more draw calls you'll have. So actually, what you want to try to do is use a texture atlas. Again, this is another thing where you can find a tool to try to automate this, but it reduces your draw calls. Also, transparency, really difficult, because then you get into the situation of compositing and it slows down your renders. For lighting and shadows, you want to bake lighting whatever possible. So that smushes all your lighting down pre-computed to basically like a light texture. It's an example on the right there. Light probes kind of hold extra lighting information, so you can use bake lighting, but then move an object through your scene. Fake shadow blobs, I just mean like kind of like billboarding. You take a quad and you throw a fake shadow on it and you put that under your object instead of actually having to render shadows. Okay, quality settings are also very important. So VR uses a rendering technique called forward rendering. It was a choice made because there's less latency. And for that, you want to use multi-sampling anti-aliasing. Keep the values kind of low, but whatever is best for your game. With forward rendering, you want to keep your pixel count light count low, because what that means is for every pixel you have, that's how many lights it's going to evaluate for that pixel. In player settings, there's a setting called stereo rendering method to single pass. This can help you skip some of the double rendering, but this doesn't work on all games. There's some catches to it. But I would turn it on, see if it works and helps for your game. If not, just uncheck it. And then finally, in player settings, make sure static and dynamic batching are enabled. This means that you're enabling the feature in Unity that when you checked all those static checkboxes, that they'll actually be acknowledged by Unity. Questions? Also, I just want to say, feel free to email me too. I know this was a ton of information, really fast. So if you have specific performance questions, please feel free to email me. I have business cards too. Oh, she is the microphone over there.
Will you be sharing the slide deck?
Yes, I believe the slides and videos are being shared out.
If you bounce light into an object, is that less intensive then than putting another light source?
If you bounce light into an object,
So
what
you
type?
instead of placing a separate light, you throw a white wall next to, something like that. I mean, it's
Yes, for forward rendering that VR uses. Previously in games, they used defer rendering, where you could use like almost infinite lights and be fine, because that type of rendering was good at that. Forward rendering is really bad at multiple lights. So I believe it will be better computationally, but I don't know that you'll get the visual look you want necessarily with that type of rendering.
What about level of detail on the mesh colliders?
Yeah.
Is that automatic, or do you have to do that yourself?
I believe in Unity you have to set it yourself. I believe there's like a drag and drop. You set it up the same as you would with your mesh level of details.
Over here to your, yeah. here.
Hi.
So do you know anything about the different hardwares that are out there? For instance, if there's a difference between the Oculus and Vive when it comes to processing power?
They're fairly similar. The display on the Oculus is a little different. Where it starts to change is some of the rendering technology behind Oculus and Vive. Oculus has been very good on their research blogs, publishing some of the things they're trying to do to optimize their rendering and things like user pose prediction. Otherwise, a lot of the hardware differences come down to the machine that's running it.
Hello. Hi. I'm right here.
Okay.
So you mentioned that you wouldn't recommend using transparency. So let's say there's a scene, there's a water or glass. What would you recommend to sort of avoid the performance issues?
Trying to think if there's a better solution for that. Yeah, I mean, if you can at all limit it, or like maybe it goes to opaque further out, just the more transparency it has to composite, the heavier it's going to be. Yeah, I would just do the water. It's like when it's far away from the user, try to make it opaque if you can. That's the best thing I can think of right now. Okay, I have time for one more.
Is there any way to step up your hardware and just go as hard as you can at the visuals and just have fully transparent water as far as you can see? Can you augment the system on the hardware end to scale things up?
Yeah, so this is actually a lot of what my team at Intel does. So there's various switches within Unity or that you can specify as a developer that can look into somewhat what hardware the user may have, and you can set certain settings depending on that. I think that's going to become a lot more important, especially with the WinMR headsets, because those have a much lower entry point than Oculus or Vive. So I think the game engines too, with that change in the market, are looking to add even more granularity checkboxes like that. Okay. Feel free to email me.